Memory consolidation is a category of processes that stabilize a memory trace after its initial acquisition. Consolidation is distinguished into two specific processes: synaptic consolidation, which is synonymous with late-phase LTP and occurs within the first few hours after learning, and systems consolidation, where hippocampus-dependent memories become independent of the hippocampus over a period of weeks to years. Recently, a third process has become the focus of research: reconsolidation, in which previously consolidated memories can be made label again through reactivation of the memory trace. Memory consolidation was first referred to in the writings of the renowned Roman teacher of rhetoric Quintilian. He noted the curious fact that the interval of a single night will greatly increase the strength of the memory, and presented the possibility that the power of recollection undergoes a process of ripening and maturing during the time which intervenes. The process of consolidation was later proposed based on clinical data illustrated in 1882 by Rabot's law of regression. Progressive destruction advances progressively from the unstable to the stable. This idea was elaborated on by William H. Burnham a few years later in a paper on amnesia integrating findings from experimental psychology and neurology. Coining of the term consolidation is credited to the German researchers Müller and Alfons Pelzecker, who rediscovered the concept that memory takes time to fixate or undergo Konsolidierung in their studies conducted between 1892 and 1900. The two proposed the perseveration consolidation hypothesis after they found that new information learned could disrupt information previously learned if not enough time had passed to allow the old information to be consolidated. This led to the suggestion that new memories are fragile in nature, but as time passes they become solidified. Systematic studies of anterograde amnesia started to emerge in the 1960s and 1970s. The case of Henry Molaison, formerly known as patient HM, became a landmark in studies of memory as it relates to amnesia and the removal of the hippocampal zone, and sparked massive interest in the study of brain lesions and their effect on memory. After Molaison underwent a bilateral medial temporal lobe resection to alleviate epileptic symptoms, the patient began to suffer from memory impairments. Molaison lost the ability to encode and consolidate newly learned information, leading researchers to conclude the medial temporal lobe (MTL) was an important structure involved in this process. Molaison also showed signs of retrograde amnesia spanning a period of about 3 years prior to the surgery, suggesting that recently acquired memories of as long as a couple years could remain in the MTL prior to consolidation into other brain areas. Research into other patients with resections of the MTL have shown a positive relationship between the degree of memory impairment and the extent of MTL removal, which points to a temporal gradient in the consolidating nature of the MTL. These studies were accompanied by the creation of animal models of human amnesia in an effort to identify brain substrates critical for slow consolidation. Meanwhile, neuropharmacological studies of selected brain areas began to shed light on the molecules possibly responsible for fast consolidation. In recent decades, advancements in cellular preparations, molecular biology, and neurogenetics have revolutionized the study of consolidation. Providing additional support is the study of functional brain activity in humans, which has revealed that the activity of brain regions changes over time after a new memory is acquired. This change can occur as quickly as a couple hours after the memory has been encoded, suggesting that there is a temporal dimension to the reorganization of the memory as it is represented in the brain.